Dear friends, let us discuss briefly on the instrumentation of particle size analyzer. This is a preliminary instrument we use for the characterization of nanomaterials for size and stability. How it works? It's a simple basic movement it exploits to get into the size of the particle. Generally, when we disperse a particle in a dispersal medium, it undergoes Brownian movement, that random motion. Generally, the small sized particles they move faster compared to larger sized particles. So what we do here, this instrument measures the velocity with which the particles moves in a dispersal medium that correspond to the hydrodynamic size. What is hydrodynamic size? If we measure the size of the particles, dispersing them in any medium, we call it as hydrodynamic size. Here, the principle we exploit Stokes-Einstein equations, which relates the hydrodynamic size with the diffusion movement or translation movement coefficient, as well as velocity, as well as the temperature. So, the Stokes-Einstein equation says that hydrodynamic size, which is inversely proportional to the diffusion coefficient. What do you mean? When the particles they move faster, they're smaller in size. When they are slower, they indicate the larger size particles that has been dispersed in a medium. So if you look into the instrumentation part, there is a laser source which passed over the sample. Normally we keep it in a cuvette, 100% transparent cuvette. Here you have to consider the sample preparations. Generally we go for dilution factor 1:100. Then we keep them in a water bath for complete dispersion of particles. Then only you get the good results. This laser from the source pass through the sample. Then the particles dispersed in that get scatter the light at different angles. Generally, as I mentioned earlier, large sized particles they scatter the light in the smaller angles, whereas the smaller particles they scatter at a very wider angle. That's the basics for this. Then there is an autocorrelation factor and all which works in the background to arrive at the particle size. So generally the results will be like that. You get a peak, then correspondingly you get the size. So look at here, the particle what we have in the emulsion, which indicates about 50 nanometer on average. Then the Z average also very similar to that. Very important one to consider is the polydispersed index. Generally, the particles which are dispersed properly are we call them as polydispersed nature. We have the polydispersity index less than 1 always. So which indicates the dispersity of the particles. Then stability also you can measure here through zeta potential. What is zeta potential? The charge which we absorb in the double layer or planar regions. So this zeta potential is important, which keeps the particles in a separate entity in a solution. Generally, zeta potential more than plus or minus 30 milliwatts, always it's good for stability. Okay, thank you.